Okay, so today we're going to cover greatest common factor and least common multiples relating to word problems or real life scenarios. So I have 4 problems here that have to do with real world situations where we use greatest common factor or GCF and least common multiple, which is LCM. So today we're going to find the GCF and LCM of a set of numbers, and then we're going to use real life scenarios. So for number 1, pencils come in packages of 10 and erasers come in packages of 12. Philip wants to purchase the smallest number of pencils and erasers, so he will have exactly 1 eraser per pencil. How many packages of pencils and erasers should Philip buy? Now here's the thing. The first thing you have to figure out is, am I looking for GCF or am I looking for LCM? Well, greatest common factor would be if you are going to take something and break it down into smaller parts. So whenever you're doing a factor, you're talking about breaking a number and breaking it down into smaller parts. With least common multiple, what you're doing is taking 2 numbers and finding a multiple of that number that is the first one that shows up in both lists. So for this one, he needs to buy several packages to get to that common number. So we're looking for the LCM. So we're going to take 10 and 12 and put it in an upside down birthday cake. And this is the method that we use to find GCF and LCM. So what we do is we look for a common factor. Well, they're both even, so we're going to take 2 as a common factor. 2 times 5 gets me to 10. 2 times 6 gets me to 12. 5 and 6 do not share any common factors besides 1. So we stop there and we circle the L shape for the LCM, okay? And what we're going to do is we're going to multiply 2 times 5 times 6. So 2 times 5 is 10. 10 times 6 is 60. So 60 is the number that we're looking for each set. But we have to look at each number and go back. So what times 10 will get me to 60? Well, I know that if I multiply 10 times 6, that gets me to 60. So the question that we need to answer is, how many packages of pencils and erasers should Philip buy? So if erasers come in packs of 10, we will need to buy 6 packages of erasers. And okay, so now for pencils, oh, I'm sorry, that's for pencils. My goodness, this should be pencils, sorry. Erasers come in packs of 12. So 60, what times 12 gets to 60? Well, that's 5. So we need 5 packages of erasers, because 6 times 10 gets me to 60 and 5 times 12 gets me to 60. So he'll need to buy 6 packages of pencils and 5 packages of erasers. All right, let's look at the second one. Kiara baked 30 oatmeal cookies and 48 chocolate chip cookies to package in plastic containers for her friends at school. She wants to divide the cookies into identical containers so that each container has the same number of each kind of cookie. If she wants to each container to have the greatest number of cookies possible, how many plastic containers does she need? So for this one, they're asking, they have big amounts of cookies and they need to break them down equally. So we're looking for the greatest common factor so that we know how many cookies will go in each container. So we're going to take 30 and 48, and we're going to find a common factor. They're both even, so we're going to start with 2. 2 times 15 gets me to 30, and 2 times 24 gets me to 48. 15 and 24 do not share a common factor of 2, but they do share a common factor of 3. So I'm going to create a new tier and put 3 here. 3 times 5 gets me to 15. 3 times 8 gets me to 24. 5 and 8 do not share any common factors besides 1, so we are going to stop here. And what we're looking for is the greatest common factor. Okay, so we're going to circle right here. And 2 times 3 is 6. Okay, So our greatest common factor for 30 and 48 is 6. Okay, so that means that I can take 6 plastic containers and have the same amount of cookies in each one. So she will need 6 plastic containers. Okay. All right. And just for bonus, so 6 times 5 gets me to 30. So that means she'd have 5 oatmeal cookies in each of the 6 containers, and she would have 8 chocolate chip cookies in each plastic container, because 6 times 8 gets me to 48. All right, number 3. Boxes that are 12 inches tall are being stacked next to boxes that are 18 inches tall. What is the shortest height at which the 2 stacks will be the same height? So we're going to have to add extra boxes. It looks like we're going to be putting several boxes together. So we're looking for the least common multiple, because we're not breaking a big number down into smaller parts. We're adding to it. We're multiplying. So we're going to be doing LCM. So 12 and 18 are the 2 numbers we're working with. They're both even, so we're going to pull out a 2. 2 times 6 gets me to 12. 2 times 9 gets me to 18. So 6 and 9 share a common factor of 3. So I'm going to pull that out. 3 times 2 gets me to 6, and 3 times 3 gets me to 9. 2 and 3 are both prime, so we stop. We can't go any further. And now we're going to circle the L shape to get our LCM. So 2 times 3 is 6. 6 times 2 is 12. 12 times 3 is 36. Okay, so 36 will be the inches that we need to reach. So what times 12 will get me to 36? Well, that's 3. So 3 12-inch boxes. And then 18 times 2 gets me to 36. So 2 18-inch boxes. Okay, so that is the shortest height. So the shortest height will be 36 inches. The shortest height will be 36 inches. And whenever you see a word problem, the answer always needs to be in a sentence form, because you're answering the question. So this is how we show our work, and this is how we check it, but this is the answer that we're actually looking for, the one with the sentence. Okay, last question. Beginning at 8:30 a.m., our tours, that should say tours, no wonder it was weird, tours of the National Capitol and the White House begin at a tour agency. Tours for the National Capitol leave every 15 minutes. Tours for the White House leave every 20 minutes. How often do the tours leave at the same time? Okay, so for this one, what we're doing is we're going to find the least common multiple. What they're asking is how often, like by every hour or every 2 hours, how often do they leave at the very same time? So we're going to take 15 and 20 and find a common factor. They share a common factor of 5. 5 times 3 is 15, and 5 times 4 is 20. 3 and 4 do not share any common factors besides 1, so we stop and we're going to circle the whole thing for the LCM. Now we just multiply. 5 times 3 is 15. 15 times 4 is 60. So 60 minutes, that means that the tours leave at the same time every 60 minutes. Okay. Which means every hour. 60 minutes is 1 hour. So that is the answer for number 4, and that is the end of the lesson.